Good morning, guys. We'll just wait 5 minutes for others to join us, and then we'll get started with the lecture. So we'll start at 25 past. It's 22 minutes past. Alrighty, guys, let's get started. Good morning, everybody. Great to see you. Thanks for coming to the online lecture. I really appreciate those that do come. Okay, because it makes my job and my life a lot more easier. Okay, so thanks for joining. Let's get started. Okay, so today we're continuing with math literacy. Okay, we have about 6 of these lectures. So today is the second one. So did anyone have any questions from the previous lecture, questions about board maths? Have you tried, there's a spelling error there. Have you tried any calculations? Anybody? Everyone's lazy to respond today. Okay. So follow along in the textbook. We are on pages 340 to 342. And once again, it's not Portma, it's Anderson. Okay. So let's change that quickly. All right, so today's lecture, once again, No, we aren't going to do long division. Today we are focusing on basic calculations, okay? And it's not too difficult, but the work that we do today, one of the questions is in the summative assessment. Okay, so we're going to be talking more about averages, percentages, and fractions. So in your opinion, why do you think averages and percentages are necessary? Just let me know anything that comes to your mind. Anyone? Why are, okay, let's start with averages. Why are averages necessary? Why do you need to know an average? Okay, that's a good try, D. So when we work with data, guys, it becomes crucial for us to understand this kind of information, because it gives us an understanding of what we're dealing with in any kind of context. For example, how much we're selling of a particular item in a month, okay? How many students, what is the average of students passing a particular subject, okay? And from there, we can use this data. Good. We can use this data to do more analysis and, see how we can improve or what we need to do, etc., etc. So it gives us some kind of analytical information about the standard or at which we are performing, okay, in whichever context. So it is crucial to know how to do these kinds of things. Good, Bukeka. Good, Cabello. Excellent. So yes, we can consider the requirements sales grouped according to the types of customers when we're doing sales. Okay, rounding off attendance figures when we're looking at attendance. So I can say 60% of the students came to my lecture, etc., etc. And we know this gives us some indication of what we're doing correctly, etc., etc. Okay, questions, comments? So the first one that we're going to deal with, these are averages, okay? And it's actually really easy to calculate averages. It's one of the easiest things. So averages are normally used in relation to reading and making sense of data. When data is collected about something and represented numerically, we often want to determine the information that applies across the range of participants or items in a study. So, for example, in your studies, you may want to compare your individual assignment mark to the average mark of the entire class. Okay, so in other contexts, we may want to know the average score obtained by a sports team or the average income earned by people in a particular profession. Okay, so usually if you go onto the internet and you say average earned by lecturers, and then you'll see what the average salary is earned by lecturers. Okay, so it becomes important for us when we study or when we want to know how much we can earn in a particular profession, or marks, our grades, etc., etc. So the proper mathematical term for the average is called the mean. Okay, so they always say calculate the mean of this data set. So we calculate the mean or average of a data set by adding all the values in the data set and then dividing the total by the number of values in the set. So what does that mean? So if the assignment was completed by a class of 13 students, okay, so we know it's 13 students completed the assignment, and these were their marks: 56, 76, 89, 34, 64, 62, 70, 68, 55, 61, 40, 45, and 55. So these are 13 values, and these are their marks. So we add all of the 13 values together all of these in a calculator, and then we divide by 13. Okay, and then we'll get something like 61. So that means the average for the class for the assignment is 61 out of 100. We can also say it was 61%. Are there any questions about how to calculate an average? And this question is in your assessment. So guys, I would just want to talk a little bit about this. When you're doing the assessment, I just don't want to see 61% or the average is 61. Show the calculation to get the marks. Okay, so you say plus, 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 divided by equals, and that's the average. Questions, comments? Okay, so then we get to percentages. So percentage is a numerical value expressed as a quantity out of 100. In maths terminology, you could also say that a percentage is a common fraction with a denominator of 100. Okay, so it's calculated over 100. However, we do not write it as a common fraction. Instead, we write a number with a percentage sign, which looks like 6%. Percentages are used to express quantities in an easily understandable way, which helps people conceptualize relationships between numbers easily. So for example, it is difficult for us to know whether the fact that 1,345 out of 1,987 students passed, which we don't know if it's a good result or a bad result. We need to know the percentage. It's easier for us to understand it if we say 68% of the students passed. The data is easier to understand, and I think it's supposed to be, and we have to represent the average mark achieved by the class in the example below. Okay, so it's the average as a percentage. We would write it as follows. So 64 over 100 equals 61%. Questions? Anybody? For me, I think this is quite simple, but some people might not understand. Okay, so if you had to represent an amount as a percentage, you must express the number as an amount over 100. So if you work 235 days out of 365 days and wanted to express this as a percentage, so 235 over 365 times 100 is 64.38, which means it's 64% of your time of the year that you were working. Questions? So to work out a percentage or an amount, it's really easy with a calculator, okay? So it's the same as working out a fraction of an amount. So 30 over 90, 30% of 90 is the same as 30 over 100 of 90. Yes, we do need to round it off. Okay, so we know if it's more than 5, okay, it goes to the next. And if it's below 5, it goes below. So you therefore need to find out exactly how much is 30 hundredths of 90. This would mean that you would divide 90 into 100 parts and take out 30 of those hundredths, and you could write it like this. 30 divided by 100 times 90. Don't get too confused with all this math calculations. We're just going to go 30 divided by 100 times 90, which is going to give us 27. Okay, so does anybody want to input that into the calculator and see if they get 27? Cool. Okay, so 30 over 100 divided by 100 times 90. 30 over 10 times 90 over 1, 270 over 10, and it's 27. Questions? Okay, so fractions. So fractions are parts of a whole. Like percentages, they are used to express quantities in relation to other quantities. The top number of a fraction is called the numerator and the bottom number is called the denominator. So 1/6 of a whole tells us that it is being divided into 6 parts. And of course, we take one of those parts, so it's 1/6. If we added 1/6 to 1/6 6 times, we would have 6 over 6, which is the whole bar. So we can see from the diagram below that 3 over 6 equals half, okay, because it's half of the bar. So these fractions are equivalent fractions because we represent the same amount of parts. Question. So we use equivalent fractions to compare and order fractions. We can make fractions equivalent by simplifying them or multiplying the numerator and denominator by the same number. So for example, in the below, 3 divided by 3 is 1, 6 divided by 3 is 2. So it's 1 over 2, which means it's half. Yes, Bukeka? Do you have a question, Bukeka? This one. You have a question? Oh, okay. Okay, let me know, and then I'll go to the next slide. Maybe I'm going too fast, that's why. So the numerator is the top part and the denominator is the bottom. Can I go on, Bukeka? Okay. Okay, cool. It's my pleasure. We can also multiply the numerator and denominator by the same number to get many other equivalent fractions. So 3 times 5, it will be 15. 6 times 5 will be 30, or 15 divided by 3, or 30 divided by 3, which is going to give us 5 over 10. Once the fractions have the same denominator, then you can compare them and do calculations with them. In the above example, we changed or converted 3 over 6 into a fraction with a denominator of 10 using equivalent fractions. Fractions with denominators of 10, 100, or 1000, or multiples of 10 can be written as decimal fractions. Okay, so here we got the equivalent of what they would be over 10. Okay, it makes it easier for us to understand. Okay, so we're going to do the activity 10A on page 346. Okay, let's do it. Number 2. So yes, we are making it a decimal fraction, which means that we give it a denominator of 10, or it can be 10, 100, or 1,000, any multiple of 10, and that's what we call a decimal fraction. We can even simplify further because we know it's going to be half. Okay, so any other questions? Okay, let's do 2 on page 346. Let's calculate the mean. And we'll do some more mean exercises. Guys, are we doing number 2 on page 346? Is only Bukeka doing the answer? Come on, guys, I'd like to see other people doing the average, please. Okay, Bukeka, fantastic. That answer is correct. Okay, let's do number 3 if we can. So here we want to calculate the percentage. Okay. So guys, we are on activity 10A, the third one. Good try, D. Tell me how you got 45%. So I'll put it here under how to do the calculation and then try again. So yeah, but I think you did something wrong there, right? So we take the we calculated the numbers all together, right? Monday to Friday. So Monday to Friday would be 912. Okay, and the capacity was 1,200. So if we look here, the calculation step 235 over 365, right? So it will be 912 divided by 1,200. We'd get a number which would give us 0.76. Then we times it by 100 to get the answer of 76. Yes, 76. Okay, so look at the formula of how to do it. Make sure, because if we do it like this, right? If we use the calculator, we go 912 divided by 1,200 times 100. So yeah, it's going to give us 76. Yeah. Cool. Let's do some more mean exercises, and I'll see if I can find any online for other kinds of data. Okay, let's do the first. I'll just do that one. Okay, let's do number 2. Number 2 on my screen. Can you see it? Sometimes I have the wrong share option. That's why. Do you see it, Buteka? It says example 2. Let me just share again. Yeah, this one. So what's, okay, cool. So yeah, so guys, so we calculate all of these together, 12, 14, 15, 15, 15, and 17, and we divide by 1, 2, 3, 4, 5, 6 to get the mean. So the mean should be, no? So I didn't calculate it. I was going to look at this answer, but let me just do it quickly. So 12 plus 14 plus 15 plus 15 plus 15 plus 17, and that's 88 divided by 1, 2, 3, 4, 5, 6. It's 14,6, so it's 15. And 14 and 2/3. They gave it as a fraction for some reason. Okay, let's do the next one. Example number 3. It was right, your answer. Sorry, because I was busy calculating. So it's 14,6, so it's 15. Yeah, so 2/3. So 15. Let's do number 3. Guys, you know what was happening with my sound? Now it's better. It's because they were cutting the grass outside and then I was using my headphones. So I think it's better now, yeah? And guys, if there's a problem with my sound, tell me in the beginning of the lecture. It's better now, yeah, Bukeka? Yeah. Okay, let me calculate and see. I don't get that answer. Okay, let's everybody calculate and see what they get. Yes, D, you can ask. Ah, yes, Cabello, that's correct, actually. Yes, D, you can ask the question. You can open the mic. Guys, we have a few minutes. Let's go into the next lecture. In case maybe I'll find more maths things for us to do online and we can do it together. So here's the link. Okay, go there and I'll meet you there. So guys, I put the link in the chat. Everybody go there and I'll see you there. So I'll answer your question in the next lecture meeting. Okay, Dee, please ask your friend to send me an email with what she requires, and I'll do my best to help her. Okay, I see there's only a few of us, so let's try to calculate the percentage here, guys. Let's do, here, find the percentage of a quantity. Is everybody trying number one? Okay. Try it with the calculator as well, Bukeka. Okay. Good try, Bukeka. So with this one, okay, it's if we use a calculator, if you have a calculator, okay, we can go 340 times 20%, and it gives us 68. Try it. Yeah. I think these are a little bit difficult. Let me see if I can find easier ones. Okay, let's do this one, guys. Let's do the first one. Good. So, Bukeka, you can look at Cabello's methodology and try as well. Good. Let's do the second one. Good. With maths, it's always about the formula. Cabello, I think it's 28. Yeah, 28. Good. Let's do the third one. Yeah. Cool. The next one. Good. So we're doing 90% of 100. Yeah, that's easy. Okay, the next one, 50%, that's easy. So let's do 80% of 20. Cool, that's good. 16, excellent, 16. Okay, 20% of 85, let's do that one. Good, and then we'll do the last one, 40% of 35. Excellent, 14. Cool. Okay, guys, so we'll stop there for today. Okay. I will check. Next week we will be on campus, so I will check if I can find more exercises for us to do. And we'll see if we can do some more maths exercises so we can get a little bit more practice. Okay. So the thing is that if we just have a formula, everything will be cool. That's the main thing, is understanding the formula. All right, any questions, comments? Okay, cool. So I will see you guys next week. What are we going to do next week? Let's wrap up the class. So it's going to be on campus. We're going to talk about decimals, rounding off numbers, and ratios. You should think about how we could use decimal fractions in financial data. Okay, so remember, with maths or with anything, the key is to practice, practice, practice. Okay. So guys, have a good week further and see you next week. Bye, Bukeka. Bye, Dee. Bye, Cabello. Bye.